Alright, in class today we went over solving quadratics and simplifying radicals. We would like to look at this again, make sure we know what we're doing for solving quadratics, simplifying radicals. The first thing we did was we looked at things with perfect squares, because if there's perfect squares, we can use square roots to solve this thing. If x squared equals 25, here's the first problem I'm looking at, x squared equals 25. What can we do? I have a perfect square. I can take the square root. X equals, if I take the square root of 25, there's two answers that work, positive 5 or negative 5, which I will now write, I will no longer write positive 5 and negative 5, I'll write plus or minus 5. Just a space saver technique, plus or minus 5. How about over here? I have the equation x minus 4 squared equals 25. Is this a perfect square? Yes, so we're going to do the same thing. I'm going to take the square root of both sides. If I take the square root of x minus 4 squared, I get x minus 4. If I take the square root of 25, like I just said, I get plus or minus 5. Have I solved this? Do I know what x is? Absolutely not. I'm going to add 4 to both sides. I get x equals 4 plus or minus 5. And this might be the first time I've seen this plus or minus notation in an actual problem. What does this mean? It really means you have two things going on and we need to solve both of them. It really means x equals 4 plus 5 or x equals 4 minus 5. I can solve them both. X equals 9, x equals negative 1. Those are my two answers. You can go back and check and make sure they work. 9 minus 4 is 5, 5 squared is 25. Negative 1 minus 4 is negative 5, negative 5 squared is 25. Got the answer. Let's go do something a little bit trickier. Next problem, x minus 5 squared equals 13. Is this a perfect square? Yes. Take the square root. X minus 5 equals plus or minus the square root of 13. Do I know the square root of 13? No, I definitely don't. So I can't do anything with that. There's no perfect squares to go in there. I can't even simplify that thing. So I just leave it as plus or minus radical 13. Do I have x by itself though? Not yet. Add 5 to both sides. X equals 5 plus or minus radical 13. Is that okay? Can I leave an answer like that? Yeah, I can't add the radical 13 to the 5. So I can't leave the answer like that. It's a weird looking answer. It's the first time we've really left answers looking weird like that, but it's definitely okay. Let's look at something a little bit harder. X minus 5 squared equals 28. Perfect square? Yes. Take square root. X minus 5 equals plus or minus radical 28. Okay, this looks similar to this problem. Add 5 to both sides, right? Yeah, add 5 to both sides. X equals 5 plus or minus radical 28. Are we done? We're not. But I don't know how to go any farther right now, so I'm going to come back to this in just a second. Let's go move on a little bit. My problem is this radical. This isn't all the way simplified, so I'm going to show you how to simplify a radical. We'll come back and we'll finish this problem. So let's go down here and look at this. Radical 200. If I want to simplify a radical, that means I cannot have any perfect squares inside. Simplifying a radical means no perfect squares inside the radical. This ends up being a pretty easy thing to do, no perfect squares inside the radical. This ends up being a pretty easy thing to do because as long as we have our perfect squares memorized, we can just take them out. The square root of 200, is there any perfect squares that go into 200? So you run through your list of perfect squares. 1, yeah, but we don't really worry about 1. 4 does. We want to see if there's anything bigger. 25 is a perfect square, that goes in 200. That's good. Is there anything bigger though? So we go up 100. 100 is a perfect square. 100 goes in there. So what I'm going to do is I'm going to say 200 is the same thing as 100 times 2, which is okay mathematically. Square root of 100 times 2 is the same thing as square root of 200. 100 times 2 equals 200. But what I can do is I can split up the radical now. Radical 100 times radical 2. Radical 100 is 10. Radical 2. Done. This is simplified because I've taken out all the perfect squares. There's no more perfect squares inside radical 2. Radical 2 won't simplify anymore, but I do have the 10 out, so we're done. I'm going to go over here and look at another one. Let's practice another one. Radical 12. So, following the same kind of process we just did, is there any square roots, perfect squares, that go into 12? Do any perfect squares go into 12? Well, you sit there and you go, okay, well 6 times 2 goes in it, but 6 isn't a perfect square and 2 isn't a perfect square. So I'm going to try and find something that is a perfect square. What about 4 times 3? 4 times 3. 4 is a perfect square. 4 goes into 12. 4 times 3 is 12. So all I can do is I can split up my radical. Radical 4 times radical 3. Radical 4 is 2 times radical 3. Simplified? Yes, because 3 cannot be simplified anymore. There's no more perfect squares to go into 3. One more. How about the square root of 30? Can I simplify the square root of 30? Only if I can find a perfect square that goes into 30. So I go through the perfect squares. 1 does, but that doesn't change the problem. 4, no, 4 doesn't go into 30. 9, no, 9 doesn't go into 30. 16, no, 16 doesn't go into 30. 25, no, 25 doesn't go into 30. Since I have no perfect squares to go in here, and then I'm done. It's simplified. That doesn't simplify anymore. It seems weird that those would simplify like that and 30 wouldn't, but there's no perfect squares going to radical 30, so we're not going to worry about it. Let's go back up to this problem for a second. Radical 28. Can I simplify this radical? Yeah. Just make a little note right here. Radical 28 is the same thing as radical as perfect squares. 4 times 7. Take the square root of 4, 2 times the square root of 7. So radical 28 is really just 2 radical 7. So my problem is 5 plus or minus 2 radical 7. These aren't like terms. We're not going to add these together because that has a radical 7 within that, doesn't. So we're not going to put those together. But this is how any answer would look, and so we'll leave the answer like that. What have we done? Simplifying things that have perfect squares and simplifying radicals, and your homework is based on that stuff tonight. I do want to look at one more thing. What happens if we actually want to solve a quadratic and we don't have a perfect square? Here's a quadratic and this isn't a perfect square. So what do we do? Well, here's what I'm going to do. I'm going to take this, and the first step in solving a quadratic is get everything on the same side. If we're going to solve a quadratic, we're going to try and do it by factoring. We first want to be able to look at it in standard form. So the first step to solve a quadratic, put it in standard form. Is this in standard form? Absolutely. So once it's in standard form, let's see if we can factor it. If we can factor it, we're good to go. We can figure out this thing. Can we factor this? I need two numbers that multiply to -8 that add to -7. Pretty easily done. X minus 8, x plus 1 equals 0. Now our problem is, and we went over this in class, the zero product property, if I have two things that multiply and give me 0, that means one or the other of them has to be 0. It's the only way it works. So either x minus 8 equals 0 or x plus 1 equals 0. That's the only way I can multiply these two things together and get 0. Which means x equals 8 or x equals -1. So my solution set is -1 or 8. Those are my two answers. -1 and 8. And you put in -1 or 8 in here, you get the right answer. We can do that real quick. If you put in 8 squared is 64, minus 7 times 8, which is 56. 64 minus 56 is 8. 8 minus 8 is 0. It works. -1, -1 squared is 1. -1 times 7 is 7. 1 plus 7 is 8. Minus 8 is 0. And we've got that one solved. Those are my two answers, my solutions. Try another one over here. I just want to see if I can factor this first. It's in standard form already. I see if I can factor it. Two numbers that multiply to -70 that add to -3. How about -10 and +7? I have two things, they multiply together, they give me 0. So I can use zero product property. X minus 10, x plus 7 equals 0. So x equals +10, x equals -7. My solution's -7, 10. There's my two answers. What happens if I had an equation like this? X squared plus 3x plus 5. Does that factor? No. And if it doesn't factor, we'll have to do something else, but we'll leave that for another day. This, as of right now, we can't solve. If it's factorable, we can solve it. If it had perfect squares in it, we can solve it. And we'll head on to things that don't have perfect squares tomorrow.